Welcome to the new video. Subscribe to the channel and like it. And we are starting. As we know, the James Webb Telescope has reached its permanent location at the Lagrange point, where it can remain stationary as the gravitational fields of the Earth and the Sun cancel each other out. It took several months to fully prepare the giant telescope for work. All four scientific instruments have completed hummingbirds and can already take well-focused images. For an example, please look at the parallel comparison of the neighboring Webb to the second one, the same galaxy that was taken by the Spitzer Space Telescope. While Spencer's image shows 7 blurry nearby stars in a large new cloud grave, James Webb showed not only the same stars in sharp detail, but also thin clouds, interstellar gas, as well as hundreds of stock stars and galaxies. The quality of the optics of the new telescope exceeded all expectations of the developers. He posted another new test image taken with the fine guidance sensor. Here is a mosaic assembled in false colors in a 32-hour test. Bright stars stand out with their 6 long, well-defined stock peaks. This is the effect of the 6-sided Webb mirror segments. After the final test, James Webb finally began to share with us the really amazing work that has been done lately, and we hasten to share with you. Here is a snapshot of NGC 3132 South Nebula. The ring is a bright and well-studied planetary nebula in the constellation of the Pars. Its distance from the Earth is estimated at about 2,500,000 light-years. At the center of the nebula is a white dwarf. This is a parallel comparison, showing an observation of the Ring Nebula or the Southern Ring Nebula in near-infrared on the left and in mid-infrared on the right. In a near-infrared camera image, a white dwarf appears to the lower left of the bright central star, partially obscured by a sleepy burst. The same star appears but is brighter, larger and redder in the mid-infrared image of the world. This white dwarf is covered with a thick layer of dust, which makes it seem to look different in the image, because the standards in the world collect light with different wavelengths. And in front of you is the second picture, the Carina Nebula, located in the constellation Carina, 7.6 thousand light-years from the Sun. This is one of the largest star formation regions in our Milky Way galaxy. The height of the tallest space rocks in this image is about 7 light-years. Inside the Carina Nebula is the Homunculus Nebula, the Keyhole Nebula, and several open star clusters. The nebula contains a system of 2 giant spheres HD 93-129 and several other large young stars, and is one of the brightest regions in the galaxy. It is 4 times larger than the more famous Orion Nebula. But James Webb never ceases to please. Before you is a group of 4 galaxies. Stephen's Queen Tet. It is located in the constellation Pegasus, 290 million light-years from the Sun. There is also a 5th galaxy, NGC 7320. Most bright, but still closer to the Milky Way. Although visually it seems that it is included in this compact group. The James Webb Telescope was able to show details that were previously unavailable. For example, that 4 out of 5 galaxies are in constant interaction. During the study, the telescope showed the presence of a huge galactic shock wave produced by one of the galaxies, which falls on another at a speed of millions of kilometers per hour. Fourth photo. Before us are clusters of galaxies SMCS 0723. What was it like 4.6 billion years ago? They also cover a section of the sky about the size of a grain of sand, which lies on the finger of an outstretched hand. The combined mass of this cluster of galaxies acts like gravitational lenses, magnifying far more distant galaxies. Behind it, the photo consists of several images taken by the mirror telescope's infrared camera over a period of 12 hours. As we have seen, James Webb allowed us to look far into the past. This is possible because the telescope is capable of picking up signals up to 13.5 billion light-years away. That is, he will be able to look at the universe as it looked just 200 million years after the Big Bang. Well, James Webb's goals are getting more and more interesting. We look forward to new incredible discoveries from the most powerful space telescope ever built by man. Like if you liked it and subscribe to the channel.